Hi, I'm Sarah and I'm your Physics Ace tutor. Year 12, let's answer this Module 5 question together. We have a sphere that's launched at 45 degrees to the horizontal from a high cliff. The sphere lands at 60 degrees to the horizontal below the cliff, and the sphere reaches a maximum height after 1.5 seconds. The question asks, what is the total time of flight for this sphere? So to answer this question, we actually need to break it up into two parts. First of all, let's look at the motions between your starting point and also your maximum height. And let's break up our motion into our two dimensions, our vertical and our horizontal motion. Now, for our vertical motion, we know that initially we don't know what our initial vertical velocity is. Acceleration should be negative 9.8. Your velocity at your maximum height should be 0, and your time it takes to do that should be 1.5 seconds. So using v equals to u plus at, we should get that our initial vertical velocity should be 14.7 meters per second. Now, going on from this, if we analyze our initial motion, we know that if it is thrown at 45 degrees, this will form a nice right angle isosceles triangle, meaning our initial horizontal velocity will also be at 14.7 meters per second. Now, since we know in horizontal motion for parabolic projectile motion that there is no net force in that direction, actually our horizontal velocity should remain at 14.7 throughout the entire flight. What that means is we can carry this forward until the end over here and know that at this motion when we're moving downwards, our horizontal velocity is 14.7, and since we can create a right angle triangle with 60 degrees as the acute angle, using trig, we can figure out our final vertical velocity, which is going at 25.46 downwards. So what we can do finally is to look at the final part of our motion when we're moving diagonally downwards. We know that we are traveling downwards at 25.46. We know that at the start of the entire thing, we had our upwards motion of 14.7, and we know that our acceleration is negative 9.8. So to find the total time of flight, all we have to do is plug it into the equation of v equals to u plus at, and we should get 4.1 seconds as our answer. Hopefully this helped you with your Module 5.